In the next problem, a 75 milliliter solution of HCl with an unknown concentration is titrated to the equivalence point with 27.3 milliliters of 0.157 molar CaOH2. What was the concentration of the HCl in the original solution? So as with any good chemistry problem, we have to balance the equation first. And we'll start with the Cl's. There's two Cl's right here. So in order to match that on this side, I'm going to put a 2 here. And now we have 2 H's and 2 H's. So in order, that makes 4 total H's on this side. In order to match that on this side, we have to put a 2 here. And then now we have 2 O's, 1 Ca, and 1 Ca. So this is, put a 1 here and a 1 there. So now it makes things simpler if we draw a diagram, as with any good chemistry problem. So here's our initial HCl solution. We got some H pluses and some Cl minuses swimming around. And we have our other solution of CaOH2. And we have Ca2 plus and 2 OH minus ions swimming around in here. So now what the problem says we do is we're adding this to there, this CaOH2 into the HCl, or I guess the other way around, if you want to think about it that way, put it the other way, whatever floats your boat. I hope. And so now we know that we have 75 milliliters, which is 0.75, if my memory serves, milliliters right here. And we have 27.3, which is 0.0273 liters. This is liters, my apologies. In here, and this is 0.157 molars, and concentration is unknown for this one. So now the goal of the problem is to find the initial concentration of HCl in there. So what we're going to do is, in order to do that, we're going to need to use the equation moles equals concentration times volume, which looks a little something like this. So this is what we're gonna. This is our goal, is to use this in the end. And we already have volume, which is this right here, which goes into here. And now, in order to find concentration, we still need moles. So now we got to figure out how to find moles. Well, how do you do that? I'm about to tell you. You're going to use this little nifty solution here in order to find the moles. And in order to do that, you're essentially going to use the exact same equation. So you have your moles. I'll come over onto this side now, change things up. Equals 0.0273 liters times point, which should be a 157 molar of CaOH2, which is going to give us a nifty little answer, which our calculator is going to give us. So moles, and we multiply this, equals 0.0042861. So that gave us moles of CaOH2, but we don't want that. We want moles of HCl. So in order to do that, we're going to use the stoichiometry that we just found here in order to convert our moles of CaOH2 into moles of HCl. So we have 0.004286 let me shift that over a bit so we have room. 0.004286 moles of CaOH2. We're going to want to multiply that by our stoichiometry in order to convert moles of this into moles of this. And we can do that because we're at the equivalence point, which means they're both used up entirely. So however many moles of this has to directly relate to how many moles of this we have. So now we're going to do 1 mole of CaOH2. So for every mole of CaOH2, there's 2 moles of HCl. And our units indeed cancel, which gives us an answer of 0.00085722 moles of HCl. So now we have moles of HCl and we have volume of HCl. We can use this nifty little equation, which is very important, in order to find our concentration. Right here is what we're looking for. So in order to do that, we're going to kind of massage the formula a little bit and get concentration equals moles over volume. That looks good enough. So our concentration of HCl is equal to this one we just found, 0.00855722 over our volume, which was given to us in the problem up here, which we also converted to liters, which is 0.075 liters. There we get that. Plug numbers into our calculators. Yep, made a mistake. I apologize. Gives us 0.114296 molars. And this is of HCl. So a quick recap in the problem. We were given volume of HCl and volume of CaOH2 and concentration of CaOH2. We used the volume and concentration of CaOH2 to find our moles of CaOH2, which we then used our stoichiometry to convert moles of CaOH2 into moles of HCl. And with moles of HCl, we could use this equation again in order to find concentration of HCl, which is a little messy, but it's okay. Some things to watch out for. Oftentimes, people, including myself originally, thought that you wanted to use the formula M1V1 equals M2V2. Unfortunately, that's bad in this situation because in this equation, you're talking about if we started off with moles and volume of one thing and then we added the same thing to that. But in this situation, we started off with 2 different things and added them together. So this equation is useless because this one only works if you're doing the same thing. One other thing to watch out for is you got to make sure that you know what the problem is asking for. So the problem in this case was asking for concentration in the original solution of HCl. Now sometimes problems could ask for concentration in the final solution, and in that case, whenever you get to this step right here, you're going to want to use the total volume of these 2 things added together, because that would be that's the final solution we have. But since it asked for the original solution, we only use the volume of the original solution. Please let me know if you have any questions, and I will see you in class on the next day we have it.